So, hello everyone. Today we are going to start the fluid mechanics. So, first of all, we will define what is fluid. So, fluid is a substance that has that deforms continuously under the application of tangential oblique shear force, no matter how small the shear force is. And due to this continuous continuous deformation, due to this continuous deformation under shear stress constitute flow. So basically we defined fluid as any substance which deforms continuously under the application of a shear force, no matter how small the shear force. So this element will move to here after this here, then this here, and it will constitute a flow. Now, basic question arises: what is difference between solid and fluid? So, what are the basic difference between solid and fluid? So, we write here solid. The most common difference we observe that the molecules in solid are closely, whereas in case of fluid, it is loosely packed. So, if molecules are closely packed, then the intermolecular forces of interaction, intermolecular forces are strong. Where the intermolecular forces are weak. Now we come to the third difference, which is very vital. Means in solid, if we apply, if we apply a shear force or shear stress, then we have a definite deformation. Suppose in this case it is a solid body, and here if shear stress is applied, then we can have a definite deformation, let it be alpha. then the material will break. But in case of fluid, if we apply shear stress, it will not have a definite deformation. मतलब क्या है कि उसका जो शेप जो डिफॉर्म करेगा उसका वैल्यू को डेफिनेटली होगा रेदर इट विल हैव a continuous deformation. Rather will have a continuous deformation. And in fluid, rate of deformation is of more importance to us. So this is the basic difference between solid and fluid. There could be many more different, but these are the basic things which need to know before starting the chapter. Now, one concept is there, concept of continuum. Continuum approach. Basically, in this, there is a concept that if mean free path length is much less than the system dimension, if the mean free path length is much less than the system dimension, then we can apply the concept of continuum. So basically, what is this mean is that if we have the mean free path length is very small and the system length is much higher, that means there is large number of molecules. And if there is large number of molecules, the variation in parameters or randomness associated with the local molecule remove the effect in the average calculation. That's why if we calculate by continuous approach or macroscopic approach, then there will be not much effect of the local variation in parameters due to the molecule randomness associated with certain local molecules. So this here we can use the concept of continuum. And to define this, we have a parameter known as Knudsen number, which is equal to lambda by L. Lambda is mean free path length. Lambda is mean free path length. L is system dimension. Mean free path length is what is it? We can define it as the average distance traveled by the molecules between successive collision. So what is that? So this is a molecule and this molecule will just collide here and again following some random path it collide here. So this distance is called the mean free path length. So if we have lambda greater than L, then Knudsen number will be greater than 1, and if lambda is less than L, then Knudsen number will be less than 1. If lambda is much less than n, then Knudsen number will be much less than 1, which means that there is large number of molecule and hence continuum approach can be applied. And if lambda is much larger than L and there is a thumb rule that if Knudsen number is greater than 10, then it will have a free molecular movement, which means that there is a very less number of molecule which constitute the volume. Hence, this is the continuum approach. Now, after that, we are going to study about some fluid properties. So, the first property we study is specific volume, or we call it as density. So, basically, it is defined as mass upon volume. So, we need not to discuss it much in detail because all of you are studying about density. If it is specific gravity represented by this. So, specific gravity S is defined as the ratio of density of the liquid or gas, density of the substance upon density of standard fluid. This is basically ratio, and standard fluid in case of liquid we have water, and that too at 1 atmospheric pressure and 4 degrees density of water. We will take density of water which is at 1 atmospheric pressure and 4 degrees. In case of gas, it is either hydrogen or air whose condition is not specifically defined like in water we have 1 atmosphere plus 4 degrees centigrade, but in case of air or hydrogen the condition is not specifically defined but it will be provided in the question. Now after this we are going to discuss about a very important property which is termed as viscosity. Before discussing the viscosity, we will talk about a concept called no slip condition. No slip condition or no slip boundary condition. So suppose This is a flat plate over which fluid is flowing. So the molecule which is, let me draw with another, we'll take blue. So the molecules which are in contact with the wall or surface will acquire the velocity of the surface. So molecules in contact with the wall or surface will acquire the velocity of the surface. So why I have written the acquired the velocity of surface? Because the surface I like here I represented it is in fixed or it may be moving. So we have to consider if it is fixed, then it will have zero velocity. But if it is moving, then relative to the wall it is zero. But when we will see from outside, it will have the velocity of the surface. So that's why molecule in contact will acquire the velocity of the surface. Suppose in this case it is having zero velocity. So this condition is termed as no slip boundary condition. Now the layer adjacent to this molecule will also experience the force, but it will not have, but the force will not be due to the direct impact of the wall. It will be due to this molecular layer. Hence, there must be some property which offer this force, and that is defined as viscosity. So basically, viscosity is defined as internal resisting force offered by one layer of fluid to the adjacent layer. Adjacent layer internal resisting force offered by one layer of fluid to the adjacent layer, and this property is termed as viscosity. Viscosity is always there, but it will come into force only when the fluid is in flowing condition. So this is very important point. Viscosity is always there, but it will come into effect only when the fluid is in kinematic condition, not static condition. Kinematic condition and not dynamic condition. Sorry, this one. Not static condition. Now, related to viscosity, we have a lot of that Newton law of viscosity. This law defines as shear stress tau is directly proportional to the rate of change of velocity perpet- with respect to the perpendicular to the flow direction of flow of the velocity, reduction of velocity. Suppose we have a fluid flowing in this direction. So at this point, to the motion condition, velocity is zero, and gradually the velocity increases, and it requires the free stream velocity. Suppose it has u, and this distance is y. Therefore, for this condition, du by dy may be written as u upon y. This is linear velocity profile. And if we remove this coefficient, it is equal to mu du upon dy, where mu is termed as coefficient of viscosity or dynamic viscosity, and its unit is Pascal second.